My dear students, in my previous video, I have introduced the 12th standard state board syllabus mathematics subject. In that state board syllabus 12th standard mathematics, I have introduced the topic, 12th topic, discrete mathematics, and in that topic we will see mathematical logic. We have seen mathematical logic in our previous video. On continuation of that mathematical logic, in this video I am going to introduce logical connectives and truth tables. In the previous video, in the topic logical mathematical logic, we have seen so many types of sentences, some 5 types of sentences and examples of some statements or sentences also we have seen. And statements, simple statements, compound statements also we have seen, and we have defined those simple statements and compound statements also. Now in this video, we will see logical connectives and the truth table. Logical connectives. Connectives means a word or group of words are used to connect some 2 or more sentences or more statements. In this logical mathematics or mathematical logic, we are using some words or group of words to connect the statements. That's why they are called logical connectives. The logical connectives are used to connect the statements. Those are 1 and 2 or 3, if then 4, if and only if, and only if and only if, not. These are called logical connectives. And is also called conjunction. And by symbol it is used as like that, conjunction, or is disjunction. By symbol it is denoted as inverted cap. Conjunction is cap notation, disjunction is inverted cap. As in the case of set language, it is intersection, it is union, like that. As in the set language topic, this is intersection, and or is union, like that. Intersection symbol is treated as cap notation. Union symbol is treated as inverted cap notation. If then is called a conditional statement. If then is called a conditional statement. It is denoted by P, if then Q. P, if P then Q. It is like that. If P, it is a single conditional statement. If P then Q, it can be treated as P, if P then Q. This is a single conditional statement. If and only it is called biconditional statement. It is biconditional statement. If and only if is biconditional, that is P two-way implied Q. Like that. If and only if is P, if and only if Q, biconditional statement. And not is called a negation. Negation. It is denoted as like that, symbol by negation P. Not P means negation P. This is called not P. See, these 5 symbols are called, words or group of words are called logical connectives, and is as in the set language union or by our mathematical logic topic, it is denoted as conjunction. It is denoted by cap notation, and or is denoted as inverted cap, and it is called disjunction. If then, it is if P then Q. It is a single condition statement. P if P then Q. If and only if it is biconditional statement. P 2A implied Q. If P, if and only if Q. Not means negation, negative of P. So if P is one statement, say Delhi is the capital of India is P, then negation P is Delhi is not the capital of India, like that. True or false? The statement of the truth value may be, then the truth value of the statement may be false or true. It is immaterial. Negation means just opposite of the given statement. And using these logical connectives, I am going to construct truth tables. Okay. First, I am going to construct a truth table for conjunction. First table, truth table for conjunction. That means and conjunction. P one statement, Q is another statement. If P is the first statement, it has T, T and F, F. True values of this statement P is T, T, F, F. See, if there are 2 variables, we have 4 rows. If there are 2 variables in the truth table, we have 4 rows in the truth table. That means 2 power 2, that is equal to 4 rows. We have 4 rows in the truth table. Why? We are having 2 variables. If you are having 2 variables, P and Q, then your truth table containing 4 rows. That means 2 power 2 rows. That is 4 rows. So first column T, T, F, F. Next second column Q variable consisting of alternatively T and F. Next P conjunction Q. In this case, both the P and Q are T, then the truth value is T. Both P, the statement P and Q are having truth values T and T, then P conjunction Q is T. Otherwise, rest of the 3 are false. This is a truth table. That is, conjunction, if both P and Q are having truth value T and T, then conjunction is T. Rest, if any one of is having false, the statement P conjunction Q is false. Both are false, the conjunction value is also false. This is the truth table for conjunction. This is the truth table for conjunction. It has 4 rows because this table containing 2 variables. We have 2 power 2 4 rows. Next, I am going to construct the truth table for disjunction. Here I am writing that this is conjunction. Truth table for conjunction. Or otherwise and. Next, I am going to construct the second truth table for disjunction. By symbol, it is inverted cap, or it is also called OR. OR. Here also we have two variables P and Q. The first column is as usual T and FF, because 2T and 2F are alternatively 2T and 2F, and Q column is alternatively T and F. This is the method of writing the column. P, 2T's and 2F, and Q is T and F alternatively, right? Next one, third column is P disjunction Q. In this case, if both the values are false, the disjunction value is also false. Otherwise, rest all true. If anyone is T, the truth value is T. If all two P and Q, two variables having the truth value T, the disjunction value is also T. Any one variable containing the truth value T, then the disjunction is T. If both are F, the disjunction is F. So this is the truth table for disjunction. You remember these two truth tables and are very, very important to solve the problems or to construct the truth tables in the exercise. We have to remember these two tables, these two truth tables. We have to remember for solving the problems. See, for disjunction, both are T, the truth value is T. Sorry, for conjunction, both are T, the truth value is T, conjunction is T, otherwise all the three are false. Whereas in the case of disjunction, both are F, the disjunction is F, and any T, if you find, the truth value is T. If you find both T, the truth value is T. One T or one F or one T, the truth value is T. If you find any one T or both T, the truth value is T. So disjunction means both are false, the disjunction is false. The rest are true. For conjunction, both are T, the truth value is T, the rest of the rows are false. These two tables are very, very important for our solving the problems. And the next, third one is not. I am going to construct the truth table for not. That means the symbol is this, not negation table. For negation, you have only one variable P, another one is negation P. Since this is one variable, you have two rows only, 2 power 1, that is equal to 2 rows only you have. For truth table, you have 2 rows. P and negation P, that is one T and one F. If P is T, negation P is F. If P is F, negation P is T. That's all. That's all about this. This is the truth table for negation not. P and negation P. If P is true, negation P is false. If P is false, negation P is true. Opposite truth value you have to consider for negation. If P is true, negation is false. If P is false, negation is true. Like that, the negation table is constructed. These three tables are very important. Next, I will go to the single conditional statement. If, then. Since this negation table containing only one variable, therefore you get 2 power 1 equal to 2 rows only you have in the table, truth table. If you have 2 variables, you have 4 values, 2 power 2, 4 values, 4 rows you have. single conditional statement. If then. Fourth one is if P then Q. That is if then. For that, if Delhi is the capital of India, if Delhi is capital of India, then Ooty not in Kerala. Ooty is not in Kerala. First statement, if Delhi is the capital of India, is P, the variable P. P is if Delhi, if not, don't write if, that is Delhi is the capital of India. Delhi is the capital of India is statement P, and Q is Ooty not in Kerala. Ooty is not in Kerala. To connect these two statements, if Delhi is the capital of India, then Ooty is not in Kerala. These two, P and Q, are not going to give any meaning. They are not going to imply any meaning. Connection of these two sentences will not give any meaning. Meaning is not necessary. Meaningful sentences need not imply. If P and Q are two different sentences, the statement, conditional statement, single conditional statement implies that the meaning of the sentences P and Q are not necessarily be meaningful. They are totally different. The truth value is also not necessary, this should be the same. That means if the sentences P and Q are two different sentences, that's all. Their truth value does not affect the truth value of other sentences, and those who need not give any meaningful sentences. Now like that, here you can write this as if P then Q. If P then Q. This is single conditional statement. If Delhi is the capital of India, then Ooty is not in Kerala. In this case, single sentences statement for truth table. If P then Q. This is table number 4. Here are also two variables P, Q. There are two variables, therefore you have two rows T, T, F, F. P, T, T, F, F. Q is alternately T, F, T, F. P then Q. In this case, if first statement is true and the second statement is false, the first statement is true and the second statement is false, the conditional statement T tends to F is false. The rest of the statements are true. This is the truth table for single conditional statement. If P, Delhi is the capital of India, this is true. Ooty is not in Kerala. Ooty is in Kerala, not in Kerala. It is also true. Q is also true. Delhi is the capital of India is true. Ooty is not in Kerala is also true. So both are true. Therefore, here P tends to Q is T. P tends to Q. If P then Q is also T, because P is true, Q is also true. Therefore, P tends to Q is T. Like that you have to consider. a single conditional statement, if the first statement is true, second statement is false. For example, Ooty is in Kerala, I can consider it is. Suppose Ooty is in Kerala. In this case, Delhi is the capital of India is true. Ooty is in Kerala is false. So in this case, P tends to Q is T tends to F. The total is false. Because this is true and this is false. Therefore, P tends to Q is false. Okay. Here, P is true. Delhi is the capital of India. Q, Ooty is in Kerala is false. Therefore, P tends to Q is false. So this is the single idea for the single conditional statement. If first statement is true, second statement is false, the P tends to Q is false. The rest of the three are true. If both are T, P tends to Q is T. F from T, first statement is false, second statement is true, P tends to Q is true. Both are false, it's also in this case conditional statement P tends to Q is also true. So this is the only case you have to remember, and this is the single conditional statement, truth table for the single conditional statement. Here also we have two variables, therefore 2 4 to 4 rows we have. And this is the if then Q truth table. Finally, the fifth one, biconditional statement. Biconditional statement, that is fifth one, biconditional statement. P if and only if Q. That means if P if and only if Q. This is P if and only if what? If and only if. If P if and only if Q, biconditional statements, two-way implied. For this also we can consider Delhi is the capital of India and if and only if Ooty is in Kerala. Like that, you consider this. In this case, biconditional statement, both both are T, the value is T. Both are F, the value is T. The rest of the middle two are, you have false values. For biconditional statement, if both P and Q are true, bicondition is true. If both P and Q are false, bicondition is true. The rest, anyone is T or anyone F is here, that biconditional statement is false. If both statements are true, if and only if statement is true. If both are false, this is true. Alternatively, you have the net answer is false. This is the if and only if truth table for two variables P and Q. This is fifth one. If and only if truth table for so far I have given 5 truth tables for you. 5 truth tables we have seen. Using these 5 truth tables, we are going to solve the exercise problems in the exercise. See, biconditional statement, you remember the middle two are false, first and last is true. If both are T, answer is T. Both are F, bicondition is T. Otherwise, F. Okay, I will stop. I have given all the 5 tables. Using these tables, we will see the problems in the next video. Thank you.